Look at that tiny white dot, right there in front of you. If I hadn't told you, you'd probably think it was just an ordinary nameless star among billions of galaxies. But it's not. That is Earth, home, the place where 8 billion souls are breathing. On Valentine's Day in 1990, when Voyager 1 was 6.4 billion kilometers away from Earth and nearing the edge of the solar system, scientists commanded it to turn its camera back for one final look at its birthplace. From that immense distance, it captured a panoramic image of the solar system. And it was Voyager 1, from that cold, distant frontier at the edge of our solar system, that sent us this perspective. A perspective so powerful it left humanity silent, because for the first time we realized we are not the center of the universe. Every 176 years, the giant planets, Jupiter, Saturn, Uranus, and Neptune, align along a unique arc. This alignment allows scientists to take advantage of a technique called gravity assist, where a spacecraft can borrow momentum from planets to accelerate without using additional fuel. Miss this window, and humanity would have to wait until the 22nd century for another similar opportunity. On September 5, 1977, amid the tense atmosphere at Cape Canaveral, the Titan IIIe Centaur rocket roared to life, tearing through the Florida sky to carry Voyager 1 into space. Ironically, despite being labeled 1, it launched 16 days later than its twin, Voyager 2. However, with a higher speed trajectory carefully calculated, Voyager 1 quickly surged ahead to become the pioneer. Its original mission was modest, to explore the systems of Jupiter and Saturn within 5 years. Yet at the moment that small, car-sized spacecraft left Earth's atmosphere, no one could have imagined it was beginning a journey with no return, a voyage that would carry it farther than anything ever built by human hands. It was 1977. The world had no internet, no smartphones. Voyager 1's memory was tens of thousands of times weaker than that of a modern car key. At its core were 3 independent computers working together to control everything from navigation in space to processing scientific data. Instead of relying on solar power like many modern spacecraft, Voyager 1 was equipped with radioisotope thermoelectric generators, converting heat from plutonium decay into electricity, allowing it to operate steadily in the deep darkness where sunlight is nearly non-existent. Inside were simple yet incredibly durable computers, capable of autonomous control and transmitting data back to Earth through a large antenna. Even with the technological limitations of the time, Voyager 1 was designed to operate for decades without repair, and in reality, it has done exactly that. After nearly 2 years gliding through the silent darkness, in March 1979, Voyager 1 finally encountered the king of the planets, Jupiter. The first images it sent back left NASA scientists stunned. Instead of a calm mass of gas, they saw a violent atmosphere filled with colossal storms raging for centuries, most notably the Great Red Spot, a storm twice the size of Earth. But the greatest surprise wasn't the planet, it was its moons. For the first time in history, Voyager 1 discovered massive volcanic eruptions on Io, making it the most geologically active body in the solar system. It also revealed Europa's icy crust, etched with mysterious cracks, hinting at a hidden ocean beneath the surface, one that could potentially harbor life. Leaving Jupiter behind, the spacecraft used another gravity assist to accelerate towards Saturn in 1980. There, Voyager 1 revealed the stunning yet harsh beauty of Saturn's intricate ring system. It navigated through delicate structures invisible to the naked eye, while executing a risky close flyby of Titan, the largest moon of Saturn. That decision to prioritize studying Titan's dense atmosphere ultimately altered Voyager 1's trajectory, slinging it upward out of the planetary plane and sending it on a solitary journey into the vast unknown. In 1990, after completing its primary scientific mission and reaching the outer edge of the solar system, astronomer Carl Sagan made a bold and poetic proposal: command the spacecraft to turn its camera back and take one final picture of home. NASA initially hesitated, concerned that sunlight might damage the sensitive instruments, but ultimately agreed. On February 14, 1990, from a record distance of about 6 billion kilometers, Voyager 1 took the shot. The result was a grainy, dim image, but one carrying a profound message. Among the scattered rays of sunlight, Earth appeared as nothing more than a tiny speck, a faint blue dot suspended in the vast emptiness. After capturing those final images of home, Voyager 1 ventured into the no-man's land of space. For more than 2 decades, it pressed on at over 60,000 kilometers per hour, heading toward the boundary of the heliosphere, a massive magnetic bubble created by the sun to shield the solar system from harmful cosmic radiation. On August 25, 2012, a historic milestone was reached. Instruments aboard the spacecraft detected a sudden drop in low-energy particles from the sun and a sharp increase in cosmic rays from beyond the galaxy. Voyager 1 had officially become the first human-made object to cross the heliopause, leaving the sun's protective embrace and entering interstellar space. From that moment on, it was no longer directly influenced by the sun, but drifted through the cold plasma and high-energy particles of the galaxy. Despite the ever-increasing distance, Voyager 1 continues to send signals back to Earth, faint but persistent, like a whisper that it still exists, still moving forward. To communicate with Voyager, we have to shout into the void, using the most powerful transmitters on Earth. A round-trip signal takes nearly 48 hours. Every time a command is sent, engineers must wait in anxious silence for 2 long days to find out whether their child is still alive. To maintain contact with something over 24 billion kilometers away, like Voyager 1, NASA relies on an extraordinarily specialized system and highly sophisticated signal processing techniques. The Deep Space Network, this is Earth's ears and voice for communicating with Voyager. It consists of massive antenna stations positioned at 3 strategic locations around the globe to ensure continuous contact as Earth rotates: Goldstone, California, USA, Madrid, Spain, and Canberra, Australia. These antennas can be as large as 70 meters in diameter. Since Voyager 1 is currently in the southern sky, only the Canberra station can directly send commands to it. Voyager 1 uses S-band and X-band frequencies to transmit data. Engineers must constantly adjust the receiving frequencies on Earth due to the Doppler effect, as the spacecraft moves away at incredible speed, around 17 kilometers per second. To keep its antenna pointed toward Earth, Voyager relies on star trackers, using the star Canopus for orientation, and small thrusters. When its primary thrusters began to degrade after decades of use, NASA successfully activated backup thrusters that had been dormant for over 30 years, allowing them to maintain the spacecraft's alignment and keep its faint signal locked onto Earth. You might wonder, how does it not collide with countless meteoroids along its journey? The truth is, that's almost impossible. Space is emptier than we can truly comprehend. To put it in perspective, if you released 20 mosquitoes inside an entire stadium, the chances of 2 of them colliding would be nearly 0. If one day humanity no longer exists on Earth, Voyager 1 will become the final and most enduring testament of our civilization. It will continue its journey like a technological ghost drifting through the eternal darkness of the universe. Even without NASA engineers sending commands from massive antenna arrays, the DSN, Voyager 1 will keep transmitting radio signals toward Earth, following the routine it was programmed to do. Those signals will echo back to a silent planet where oceans and forests slowly reclaim what were once cities. Once its plutonium power source runs out, sometime after 2030, the spacecraft will officially die in technical terms. It will no longer transmit, no longer adjust its components, becoming nothing more than a cold piece of metal drifting through the dark. On Earth, the atmosphere, water, and life itself will break down even our greatest structures, from pyramids to skyscrapers, into dust within a few thousand years. But in the vacuum of space, there is no oxygen to cause rust, no bacteria to decompose materials, and almost no erosion. Voyager 1 will endure almost forever. Aside from microscopic scratches from cosmic dust, its structure, and especially the golden record, could remain intact for millions, even billions of years. While Earth itself may be swallowed by the Sun in about 5 billion years, Voyager 1 will still be out there somewhere, drifting far across the Milky Way. Mounted on the spacecraft, carefully protected, is the Golden Record, a gold-plated copper time capsule. It contains 115 images of nature and humanity, sounds of waves, rain, and heartbeats, and music from Bach and Beethoven, along with greetings in 55 different languages. It is a message of peace, a handshake across space and time. Engraved on its cover is a pulsar map, a kind of cosmic GPS that could allow any advanced civilization to locate our solar system relative to fixed points in the galaxy. If another civilization were to receive Voyager's signal and respond, it would still take decades for that reply to reach us. The late astrophysicist Stephen Hawking once warned that attempting to contact extraterrestrial life could be extremely risky. He compared it to the encounter between indigenous peoples and Christopher Columbus. The outcome, he said, is rarely favorable for the less advanced side. But Carl Sagan, who led the Golden Record Project, believed that any civilization advanced enough to travel across interstellar space and intercept Voyager would likely have already moved beyond aggression and war. To him, Voyager 1 was a message of peace. Voyager 1 left the heliosphere, the vast bubble of magnetic fields and charged particles created by the Sun, back in 2012. Today, it is traveling through the interstellar medium, ISM, the space between stars, where matter is largely the remnants of stars that died billions of years ago. It is heading in the direction of the constellation Ophiuchus. However, it is not aimed at any specific star. Based on its current trajectory, it will take about 38,000 years to pass near the star AC plus 793888, a red dwarf in the constellation Camelopardalis. Within the solar system, we are shielded from cosmic radiation by the Sun's magnetic field. Beyond that boundary, Voyager 1 is exposed directly to high-energy particles moving close to the speed of light. These particles can penetrate its metal shell and damage onboard electronics, which is why its computer systems occasionally experience data glitches. Around 2030, when its power supply is finally depleted, the spacecraft will become a silent, lifeless object. And yet, if one day, somewhere far in the distant future, another hand touches its gold-plated surface, they will know this. We were once here. We lived, we loved, and we reached for the stars. Voyager 1, the Voyager that never runs out of time.